get started with 11.2. And what we're going to start off with is areas of circle, or the area of a circle. Now, I think pretty much all of you all know the area of a circle formula by now, or at least you've heard it. The area of a circle is, it does involve having a 2, but it is pi r squared. The area of a circle is pi r squared. So whatever the radius is, we take that value and square it. And if we're given the diameter, we can really convert it back to the radius and find the area. Or we can go the other direction. So the first problem we're going to look at is we want to find the area of a circle with a radius of 2.5 centimeters. Well, again, for us, area is equal to pi r squared. Area is equal to pi r squared. And they told us that the radius for this circle here is 2.5 centimeters. So if I want to find the area of it, what we can do is type in the calculator pi times 2.5 squared. Which is exactly, so approximately, the area is 19.63 centimeters squared. Would be the approximate area for this here. Or if we wanted to leave it in terms of pi, well, we can do 2.5 squared, which would be 6.25 pi centimeters squared. Because if we want it in terms of pi, we can really just drop the pi off and square the number 2.5 to get our answer. Are there any questions on any of this here? All right, let's look at another one. The area of a circle with a radius of 8.5 inches. Well, again, area is equal to pi r squared. So the radius for this here is 8.5. So we can plug the radius in to the formula and then just type it into the calculator. So we can do pi times 8.5 squared, which again is going to be approximately 226.98 inches squared. So for the most part, we can just type this into the calculator. Any questions on any of this here so far? Okay. Any questions on any of this here so far? Find the area of the circle given the radius. Well, for the most part, we just take the radius measure and plug it into our formula, pi r squared, and we find the area. So we'll skip that one and look at the next one because, again, it's just plugging it into the calculator. Now, for this one here, we want to find the indicated measure. Now, it wants us to find the diameter of the circle with an area of 113.1 square centimeters. Well, area is equal to pi r squared. Because that's just our formula, yes? They tell us the radius. But we know what the area is. It's 113.1. So we'll fill that in. 100. Let's put 111. 113.1 is equal to pi r squared. So we set this up like this here, and we're going to solve for the value of r. So we plugged in the area, but we don't know what the radius is, but we can solve for it. So what we can do first is we can divide both sides by pi. Because here pi and pi will cancel, giving us r squared by itself. Now this here, I'm going to leave it as this here for now, because do we have r by itself yet? Well, no, we're talking about r squared. Now we know pi is an irrational number. It's a non-repeating, non-terminating decimal. So most likely, if I type it in at this point and then continue to solve for the value of r, we're going to have to keep rounding to actually get a nice number. So I'm going to leave it as this here for now, 113.1 divided by pi. Now we're going to square root both sides, because the square root of r squared becomes r is equal to the square root of 113.1 divided by pi. Now that we do actually have the value of r by itself, then I would plug it into the calculator. Because we're going to plug it in anyways, why not wait till the end? So we're not plugging in multiple things over and over again. How many zeros? And that's our answer, yes? What did it ask for? Diameter, what did we find? The radius. So the radius is 6 point, approximately. Now what do I do to it to find the diameter? Multiply by 2, because the diameter is equal to half the radius is equal to, or the diameter is equal to twice the radius. So we get 12.00014. So approximately the radius is 6 and the diameter is 12, if we're rounding to the nearest tenth or hundredth. Any questions on any of this here? Are we good with this here? Let's look at another one. The diameter of a circle with an area of 153.94 square feet. So we want to find the diameter again. So again, we're going to stick with this formula here. Area is equal to pi r squared. Now, since we know what the area is, we're going to go on and plug it in first. We have 153.94 is equal to pi r squared. And then we can divide both sides by pi. Because pi divided by pi will simplify down, leaving us with just r squared. Now the other side we have 153.94 divided by pi. Yeah. Any questions on how we got to this point here? So what would we do next? We would square root both sides, which will tell us that r is equal to the square root of 153.94 divided by pi. Or really the radius is approximately 7. Any questions on this here so far? Well, we have one last step. We need to do what? Multiply it by 2. Yep, 0.88. So we'd get 14.00008 would be the diameter of this here. Any questions on any of this here so far? Any question on anything we've covered so far today? Okay. Do we feel comfortable with finding the radius and the diameter given the area? Yes? Okay. Then we'll move on to finding the area of a sector. Find the area of a sector. And really this is, I'm going to steal this term from Miss Kendall, but essentially you're finding the area of a pizza slice, because again, it looks like a slice we're cutting out of an entire pizza. And we're going to find the area of it. Now, just like we did for the length of a sector, we're going to do a similar process for finding the area of a sector. So the length of, not of a sector, the length of an arc, we're going to do the same thing for finding the area of a sector. Because we know that the central angle that makes up the arc is going to be part of the entire circle. And the entire circle is 360 degrees. So that's telling me I have one part of the whole. What part of the whole circle do I have? And we can use that just like we did the other day, because our overall formula for this here is really the area of a sector, and I use a sub s really to signify that we're not talking about the area of the circle, we're talking about the area of the sector, is equal to the arc measure over 360 times the area of the circle, the whole circle. And normally they won't write it this way here. Mainly, we'll end up writing it as arc degree over 360 times pi r squared. Now this here, they gave us some information. Find the areas of the sectors formed by angle UTV. So what is our arc measure? Almost. It would just be 70, because the arc measure is 70, and we would put it over. Now the radius that we have for this here is 8. So any questions on how we filled any of this in so far? Well, again, just at this point here, what we can do is we can grab the calculator and do 70 over 360 times pi times 8 squared. (112 pi over 9) would be the area of this sector. Any questions over this here so far? Now it did say find the areas. Yes? Well, the other area would be the one in blue. So the 112 pi over 9 would be our area of the red segment. Well, the area of the whole circle would not be 360. Yes. So what we could do, so I'll have to erase more in a little bit. is to find the area of the other sector. Well, we could do 360 minus 70, which is, so we can use 290 over 360 times pi times 8 squared. Because we're using the same formula, but instead of 70 degrees, the angle for the red sector, we're using 270, which is the 290, which would be the angle for the bigger segment. Because the two of those add together to be 360, yes? And at this point, again, we can type this in. (464 pi over 9) would be our answer for this here. Any questions over any of this here so far? So our two areas, I'm going to write it here. One of them is this here, 464. I don't know why I wrote 69. 464 pi over 9. The other area is 112 pi over 9, yes? We have these two. Without using the calculator, what would you guess that would happen if I added these two together? What would we get if I added these two together? Right, so if I added these, we would have 578 over 9, yes? I'm going to do this by hand. 578. So 9 can't go into 5, but 9 can go into 57. And it can go into it. So here it would be 6 times, because it would be 54. 7 minus 4 is 3. 5 minus 5 is 0. Drop the 8. There shouldn't be a 7, 8. That should be a, because 4 and 2 is a 6. 9 goes into 36 how many times? Well, we get 64 pi, yes? There shouldn't be anything surprising about this. What is the area formula for a circle? Area formula for a circle is pi r squared, yes? What's the radius for this circle? What's 8 squared? So wait a minute, when I added the two areas of the sectors together, I got 64 pi. The area of this circle is 64 pi, yes? So once I found the one area, the 112 pi over 9, well, I could have subtracted it from the area of the whole thing. Because the two sectors will add together to give me the whole area. Because that 112 pi over 9 is just the area of this piece here. The area of 64 pi is the entire circle. So if I wanted to, we could have done 64 pi minus 112 pi over 9 and actually gotten 464 pi over 9 because these two sectors add together to be the whole. Let's look at another one. Let's look at this one here. Now they told us that we want to find the area of the sector. So our area of the sector is equal to the arc measure, which is over 360 times pi r squared. And what's our radius? Well, at this point here, we can do what? (675 pi over 8). And that's the area of our section in red. That's all I have to do to find the area of this sector. Questions on this here? Yeah, if I want to find the area of the one in blue, well, I know the area of the whole circle should be 15 squared times pi, yes? Because that is the area of the entire circle. Yes? Find the areas of the sectors formed by this here. And the homework is going to ask for both. It's going to ask for the one in blue and the one in red. It's hard to tell. It won't print color on the note sheets. So the two ways we can go about finding the other area is we could do the same formula we did to find the one in red, do 360 minus 135 to get the angle, and plug it in. The other way is we can do this here, is I can type in 15 squared times 5, and 15 squared I believe is 225. Mm-hmm. 225 pi minus 675 pi over 8. And that'd be the other sector. Now, if we did it the other way, we could have done 360 minus 135. We could have plugged in this formula again, but instead of 135, we would have plugged in 225. Because 360 minus 135 is 225. Any questions on any of this here? That.
So it's just like part of the circle?
Mm-hmm. Yep. It is a part of the entire circle. Are there any questions on how we find the area of a sector? We feel comfortable with these here? Yes. Because a lot of it's just plugging this into the equation and solving. So we'll move on. Awesome. This is the last type we're going to cover. We could go through the entire process where we could actually find the value of r. We can actually find the radius from this using the fact that the area of the sector is equal to arc over 360 times the area of a circle, really pi r squared, and go through the process, essentially solving and plugging the information in. Now here, it's not wanting us to find the radius, it's just wanting to find the area of the whole circle, yes? And our formula really is telling us that the area of the sector is equal to arc over 360 times the area of the entire circle. It's pi r squared. What we've been plugging in is just the area of the circle. What do you think? Of? would be, so the area of our sector is 35. Because that's what we do know. Now our arc measure is we would divide both sides by 40 over 360. These, here we get what? I feel like I heard 350 and 50. 315. That's okay. Just wanted to make sure. Could be the area of the entire circle. Any questions on this here? It's not asking for this, but how could I find the other sector, the area of the other sector? We could do that, but there's an easier way to do it. So the one in blue, how could I find it? Well, 315 is what, the area of the entire. So we can use it, and I would agree, we are going to, I would subtract. You just have to subtract one thing. Because the area of the one part is 35. The area of the red sector and the blue sector add together to be, if I know the area of the red sector is 35, well, I can subtract it from the whole, 0. So the area of the blue sector is 280. Any questions on this here? I mean, we could take it one step further, and if I wanted to know the radius of the area of the circle, 315 is equal to what? Pi r squared. So like we did at the very beginning, we can divide it by pi and take the square root, and we have the radius. So it's not a huge step beyond it. Any questions on this here? Let's look at one last one. Area of the sector is equal to arc over 360 times the area of the circle. So for this one here, the area of our sector is now I dropped the C off because since we know that the area of the circle is what we're looking for, we don't have to denote it. We can leave that denotation there if we want, but we don't have to, especially since we know that's what we're solving for. Now what would we do next? Yes, we would divide both sides by 135 over 360. If we type that in, we get that the area of the entire circle is 128. Now doing this here, if we're given the area of the sector, we want to find the area of the entire circle. Will the answer that we get for these here always be bigger than what we were given? Why? Right, because what are we finding? The whole thing, yes? The part of it is always smaller than the hole. We're not going to come across a case with finding areas of circles where the part is going to be bigger than the hole without breaking Euclidean geometry. I believe that is it. That is all we have for